Good morning, Shankar. Sorry, good evening, Shankar. Good evening, everyone. Good evening, Saxena. Okay. So,
Good evening.
good evening. In the last weekend, we had a discussion about a few of the concepts of Docker, Travis. We visited how the circle continuous integration, continuous deployment can be done using single container deployment. And afterwards, we jumped into the basics of Jenkins. What is Jenkins? How to do the basic deployment of Jenkins? We did some hands-on, right? We actually try to deploy Jenkins using Docker in our local machine, and then we try to deploy Jenkins in EC2 instance. So that's what we had discussion about, right, last week. So we'll catch up from there. So we'll continue more and more on Docker again. Last week I also mentioned that Docker single container deployment was successful, but multi-container deployment was missing because of some upgradation that happened in the AWS side. So the container type, how to create the container type in Elastic Beanstalk was a little bit few previous container type container image type deployment was deprecated, and new way of deployment has come. So we thought of how to make it working. So I made it working. I'll show you those steps also. So let me share my screen now. Let me share my video also. Yeah. So let me share my screen. Okay. Yeah, so a lot of interesting things that we are going to discuss today. So Shankar also tried to deploy using Azure DevOps. So I was in the middle of it. So I think it is successful. Let me check it out. Okay, so I just did the Travis and Azure DevOps, Azure Web Apps deployment. It looks like it is also successful. I will check it out here somehow. I can check it out. I will just do a quick check. Maybe it is successful. Oh, why is it asking for? Hey, where are we? Okay, let me see our registration. So I'll try to see my basic customer map. Here I have deployed a few resources actually. So in Azure, everything is resource. We can actually mix all all services into a single group called resource group. So give me some time. I'll just confirm if everything is fine. So this is how the Azure portal looks like. It's also, we can try Azure also parallelly. So I was actually trying to deploy my web application here. Okay. So, okay. So my basic test web. Okay. So continuous deployment using Azure Web Apps also was successful. I can see the workload. I will actually explain it quickly. Azure also today, if there is time. Otherwise, I will continue in the next session also. Okay. So let's see. Let's see AWS where we left in the previous session. Okay. So let's get back to our slides so that we can catch up from what we left. Okay. Now, what shall we do? We'll go to our CloudX lab course. CloudX lab course should be somewhere. Okay. So last week we covered Jenkins and few Docker. So basically last week we covered topic 10. Last week and last week, both we covered topic number 10. Deploying a single container using Travis and AWS CI. Using, we can actually open our Travis CI account, which actually looks like this, right? So this is our Travis dashboard. So last week we actually went through how to create AWS account, how to create Travis account, and then how to make a deployment using continuous deployment of Travis CI into Elastic Beanstalk. So these are all the services that we have learned about. So we had a AWS account. So AWS account, which something looks like. Okay, this is Grafana. We'll discuss about Grafana in the next sessions. So AWS account, we can just go to AWS account by AWS console. Go to AWS console. We just have to log in. This is our AWS console. So we know what is Elastic Beanstalk, what is S3, what is EC2. We went through all these things, right? Using single container deployment. So we haven't covered deploying multi-container Flask deployment with Docker, right? This was, so actually this works fine. We can go through this multi-container deployment by following the steps. Only change that we have, if you go offline through this course, only change that you need to remember that while creating Elastic Beanstalk application, you need to create ECS kind of Docker container. So that I will explain you by going through it. So if you are already logged into a AWS console, you have to go to Elastic Beanstalk, right? So these steps. So these steps, if you go to topic number 12 and if you start following the steps that was mentioned here regarding multi-container deployment, if you see the slides, follow the slides. Only problem that you would be seeing is while creating Elastic Beanstalk application, here whatever application you type, my first app, and here whatever you have to choose the Docker container. And here it was before in the slides they would be mentioning about multi-container deployment, which no longer is there here now. So we don't have that option in this platform branch. So instead of that, you can just select ECS running on 64-bit Amazon Linux 2. If you select this particular option, then everything should be working fine. So once you select this one, just go for the recommended platform version and start the application. And then everything else you can actually follow from the slides that was mentioned here, and follow the steps, follow the GitHub repo, which was given to us here. Let me quickly check what is that here. Yeah, so you can just create an application here. So always remember this, you remember, right? It's very simple steps. You just need to create a Elastic Beanstalk application. And if you are going to deploy a multi-container deployment, it's very simple to select ECS running on 64-bit Amazon Linux 2. You just create that particular application. Just create that application. So you will be able to run your multi-container deployment in this particular application. How does the multi-container application work? I will just explain it to you. So it should be already there handy. I have already worked on this code. So this is the same code repo that we have. Just go to the repo, which is there in our course. Go to this, our topic here, our repo is there, right? So this is our user list repo. Then go to this repo, try to clone it, or you can just make a fork of it in your directory and play with it. You can just click on fork and fork it into your repo. I already did that. You can just fork that repo, and then from there you can catch up. So once you fork that repo, it will be there in your repo. Just let me know if you are following me. Otherwise, you can ask questions anytime. If you're stuck, I'll make sure that you are following what I'm trying to say. Just let me know. We can have a ongoing discussion, parallel discussion going on, and try to make sure that we are in sync. So I have forked that particular repo, and this is a repo that I have right now. So this particular repo is supposed to be a multi-container deployment, which you can see that we have multiple containers here. If you see Docker compose.yml, if you can run it locally, as I have already explained in the previous session, you run it using Docker compose up. The command that you actually do is Docker compose and up. It will actually run the Docker compose YAML. This is what it will run. Okay, it will run this one. So basically, Docker compose is meant to be running for only in your local machine. In your local machine, if you want to develop in your local machine, Docker test it in your local machine, then you need to use Docker compose.yml. So here you can see that Docker compose YAML has three sections basically. Three sections basically. The first section is only version. So it says which version of Docker compose YAML you are using, version number 3. Followed by second section. The second section is the service section. So this is the service section. You can see here this one. This big block is a service section, which clearly mentions that there are three kind of services: web section, Redis, Redis service section, and DB service section. So that means that we have three Docker containers that we are running under Docker Compose. So this is the web section, which contains the web application that we are going to deploy. We are deploying inside Docker, and Redis section is the in-memory DB that we are going to run, dockerized version, container version of in-memory DB that we are going to use. And the DB section basically is the database service that we are going to run, containerized, Docker-based, containerized service that we are going to use, which basically is a Postgres database. You might have heard of Postgres database, right? So we are running the Postgres database inside a Docker, and we are naming that particular Docker service as DB. So basically we have three services. One is DB, one is Redis, and one is the web application. So these three we are going to run as a part of deployment. So this first part, web application, is our source code. Our source code, we are saying that we build the web service from the build of Anil from the Docker Hub repo, Anil Budby user wish list. So how are we going to get this Anil Budby user wish list? We will get it from the Docker Hub. So Docker Hub should already be having this particular build. It should already be having that particular build. So you need to make sure that the build is there, right? So our way of doing this is, make sure that we upload that particular Docker build using travis.yml. In the travis.yml, here is what we are doing. So we are building our repo, our Docker file. We are building a Docker file, and with the tag name Anil Budby user wish list, and we are uploading it to Docker Hub via this command, Docker push Anil Budby user wish list. That is what we are doing, right? So you can see that using Docker Hub. Okay, so I was actually running the application, right? Elastic Beanstalk. So this is ready now. So our application is ready. We have the application with name My First App ready, and the environment is also ready. It says it is healthy, and by default we are running a basic application, default application that AWS uses to us. So you can just see the endpoint here by clicking on this particular endpoint, right? So just open this particular endpoint. You will see this is the default endpoint that Elastic Beanstalk deploys in our Elastic Beanstalk application environment. So we have this basic web application running. So by looking into this, you can see that the health of the deployment is successful. Now our task is to deploy a multi-container deployment in the Elastic Beanstalk. That's what we are trying to do. So we are taking we are taking help of Travis CI for that. So in the Travis CI, we have this is the commands that we do. We are already aware of. We already discussed about what how the Travis CI works for single container deployment. So the syntax is exactly the same, but in case of multi-container deployment, the difference is it is not only one single container that we are deploying. We are deploying three containers. One is the web container. Second one is the Redis container. Third one is the DB container. We are going to deploy three containers here. That you can actually see. You can see that we need three containers for DB connection and so on. So that you can actually see by looking into the either two files. One is like which I already discussed, either in docker compose.yml or another file which is docker run aws.json. These two files we are going to see how it works. So before that, I will explain you step by step how this Travis YML for multi-container deployment is working. Okay. Now, so we are saying that we are deploying a Docker kind of service here by this section. And after successful build, we want to copy that particular Docker file, Docker container, which we are going to build into Docker Hub with the name Anil Bhatt user wishlist app. So this is what after success is going to do. Let me check that. How does it work? So I'll go to Docker Hub first. Okay. So this is my Docker Hub. I am logged in. I'm logging into my Docker Hub. Just I'll sign in. Okay, so I am already signed in. So this is what is expected here in Docker Hub. I'll delete it for now, so that to make sure that it automatically gets created when I log in. So we can actually delete it. Go ahead there and there should be delete button. Yeah, go to settings, delete repository. I am going to delete the repo. You have to type user wishlist app. Done. So you have deleted the you have deleted the image from Docker Hub. Now you have deleted the image from the Docker Hub. Now what you need to do now, what the Travis YML will do is after successful build, when you do a git commit, git push, right? When you do a git push, Travis.yml will start executing, and after successful build, it will try to again deploy it to Docker Hub. So again, after the success build, you should be able to see that in my hub.docker.com Docker Hub website, I have my repository uploaded with name user wishlist, which is this one, user wishlist.app. It will get uploaded, and after the image is uploaded to that location, deployment will take place. How the deployment will take place? So we have all the options here. So from this how many? It's like 10 lines. These 10 lines actually says that you need to deploy in Elastic Beanstalk and take help of any other file which Elastic Beanstalk can understand. So Elastic Beanstalk, if you say a provider is equal to Elastic Beanstalk, it will either look for the Docker file, or in case of multi-container application, it will look for a file called docker.run.aws.json. So this JSON file, the Elastic Beanstalk will look for this particular JSON file. Okay. So JSON file will contain an array of container definitions. So this Docker.js AWS.json is similar to Docker.compose.yml. So we have seen the Docker compose.yml, right? So similar to Docker compose.yml, here Docker compose.yml is having three services: web, Redis, and DB. Similarly, our Docker AWS.json will also be having three services: container definitions. So it is an array of container definitions. You can see that this is an array of container definition, right? So this array of container definition starts from open bracket here with close bracket here. So it is an array. You can see that it is an array. This array contains three services. So each service can be seen by a curly braces open. So this curly braces open, curly braces close. This is first service. Second service is this one. This curly bracket open, curly bracket close. This is second service. Third service is this one, right? So the first service you can see, you can read. This is a set of environment variables. We have hard coded the environment variables in the Docker file itself, Docker JSON file itself. We have said what are the name, username, password for the service that we are going to use. We have given the environment variables here only. Okay, this is one way. And so you can actually literally see the user password, everything. This is what you can do. This is not a good practice. Later we will see that how we can hide the values. We should not give the password and username in the file itself so that people can read it. So instead, we will have a mechanism to hide these values in environment variables. Okay. So for now, just have learned that this is how we can actually put environment variables inside the container definitions. So we are saying that this is a DB kind of service, and we are building it from image Postgres, and we have a mount point from the um, Docker path. This is the mount point that we are going to use, where the actual uh, data means that Postgres will be having database, tables, schema, everything, right? So those information, those information, everything will be stored here in this directory path, where live Postgres data, and that is exposed as a source volume as called Postgres. So we have a volume in the end where we can use which says that host source for Postgres is mapped with name Postgres data. So finally, at the end of the day, we know that final data which is there in this one data is exposed with the source volume Postgres data. So that is how the mapping is happening here. So mapping is happening, and this particular first JSON part is about database container. So we are creating a database container called Postgres DB database container. Okay, so we are naming that particular container with the name DB. You see that this is the name called DB. Okay. Now database can be accessed via the service name called DB. So this is what is important. So you are exposing this entire container service with name DB. With port mapping is 5432. So DB, this is the service name, database service name is DB, and container port is 5432. So that's what we are doing here. Okay, and the password, everything is these are the username. We are exposing it as environment variable, Postgres user, Postgres password, and Postgres DB, and so on. Okay, now the second part is the Redis. You might be knowing about Redis, right? So basically, Redis is an in-memory database, like it's like a key value set. So you can actually read about what is Redis is. So for it is basically used for fast access. So you can see that it's an in-memory data store. Everything is stored as a key value pair, and it is always stored in RAM. So it is pretty much very fast. So it actually reduces the time which exponentially it reduces the time to actually get information for read and write access of any rather than contacting DB and getting the content from the DB, you actually can get directly from the Redis database, which is pretty much faster. So this is Redis database. You can just learn more about what is Redis nowadays. Highly scalable, highly efficient applications which is very fast data retrieval and data write. They actually rely on this in-memory data structure called Redis. So AWS has its own service, Redis-based database service also. So they call it as Elastic Cache. So AWS provides a service called Elastic Cache. Similarly, Azure also provides its own Redis solution, and Google also provides its own Redis solution. Okay. Now we are going to have this particular Redis container as a part of these lines, right? So we are going to have a Redis image. From this Redis image, we are going to build a Redis, and we are exposing it with the service name called Redis. Okay. And later, finally, our web application. This is our web application. Our web application is exposed with name web, and we are building that web from image Anil Bhatt user wish list. Anil Bhatt user wish list, which is there in Docker Hub, right? But still now that particular image is not there. It will be built runtime when we actually do some commit. So this is what our Docker Hub looks like. Nothing. We don't have that particular image right now. We will be building that. So our Docker run.aws.json is ready, and our travis.yml is also ready. So travis.yml is also ready. We have environment variables, AWS access key, AWS secret key. Last session we have already discussed how to initialize AWS access key, AWS secret key, and so on. And here also we are relying on few other things like Docker password, Docker ID in order to push the image from our local machine to the Docker Hub, using which it will be pushed from your Docker file. So our Docker file has this contents. So this is our Docker file. So it's a very simple Docker file. So we are building a image from the base image called Triangle Nginx Flask. So this is our base image we are going to build it from. So this again, it is actually pulling it from Docker Hub only. After pulling it, it will actually copy few files. So basically our Flask application, which is there in our app folder, it will copy and it will install all those requirements. So if you are aware of Python pip3, so this is actually installing all the required libraries, Python libraries to run the application. So we can see that requirement.txt is there here. It should be there here. Yeah, so we have requirement.txt. So this requirement.txt says that we need to install Flask, Redis, and Flask SQL, Alchemy, and this one. So these are all the 4 Python libraries that are required to install. So in order to install all these things, these are all available in pip3 repositories. So to just install these repositories, we need to run the command. We need to run this particular command, pip3 install -r and requirement.txt. So once this particular thing is run, right, it will install all the libraries that we are mentioned in requirement.txt inside the Docker container, which we are building from base image called Nginx. From this Nginx base image, we are installing all the required packages, and then we are copying the app from our local repository to the Docker repository. So our app folder, the entire app folder will be copied. So it's basically a simple Python application. You can see that. So this is a simple Python application. It's a Flask application, and we can see that it is running. So it's basically a Python application which actually tries to connect to database, and it will expose you a simple form where you can enter a new user, his city, and what kind of food he wants, and so on, right? So this is what it's a simple Python application. It exposes few REST APIs, root API and the save API. So two APIs it is going to expose, and we can actually enter username, place, and food. They will be exposed as UI. They will be exposed as UI, and it will try to connect to database, right? So here you can see that we are able to connect to database using this particular predefined path. So it's a hard coded as of now. It is a hard coded as this is username and this is password, and we are trying to connect to the database. Port number is this one, and this is the database name Hello Flask Dev. So here you can see this is the syntax of connecting to a Postgres SQL. So for now, for explanation purpose, we are actually uh, accessing the databases with hard-coded values. These are all the hard-coded values. So username, here you can see username, which is Hello Flask here. Password is there here. Password is there. Hello Flask is the password. And service host name. Host name is DB is the host name, followed by the port name, port number. Port number is 4545432, and the database name that you are going to connect is the Hello Flask Dev. So this is the syntax. So you can see there is a security threat here. Security problem is there. Everyone can actually see the username, password, port number, and database name. Everything you can see here, right? So in the next coming demo, next repository, we will see how we can actually eliminate this. We should not store username password directly in the code. Instead, we will store everything in as a environment variable. So that I will show you in another repo. So we have another repo. I will jump quickly to that repo and come back just so to give you a hint of how we can actually store, right? So here, if you see, so this is another way that we are going to use. So let's compare. So here you can see the database URL, how it looks like. So username, you are just not entering the real username. You are entering a environment variable, right? This is another environment variable, Postgres password. You are not entering the password directly. You are just exposing environment variable, and you are saying that this environment variable Postgres password is coming from OS environment variable Postgres password. So this Postgres password value, you will get it from operating system environment variable Postgres password, which you will enter when you create the environment in Beanstalk. Okay, so this way you are not entering that directly the username, password, DB, hostname, port, all these things you are not directly entering in the source code, but rather you are entering while deploying. While deploying into the operating system itself, in the operating system you are setting the environment variable, and the source code will actually pick from the environment variable. So this is the syntax which is more secure. You don't expose. No one can get your username password unless you have access to the machine, right? So these password can be stored like environment variable safely, and no one can actually access this particular username password. So for now, so you can see that how secure you can do. So this is a direct way. unsecured way that we can use access. But here the main intention of this demo is to actually deploy a multi-container application. So in this section, we will focus more on how multi-containers can be deployed. So this is one of the, this is our main application, which is connecting to database, and it is connecting to Redis also. Here you can see Redis, right? This particular line 17, it is actually connecting to Redis. It is connecting to, it is also again hard coded. You can see that it is connected to Redis port, host number Redis, and port number this one, and so on, right? So this is also exposed, and you have a better way of, instead of storing the host number, host port directly, you can actually mention it as an environment variable. So here you are actually storing as environment variable, port, environment variable, environment variable, so host, environment variable, port. So that is what you are mentioning it here, which you are getting from os.environment.redis host, right? Okay. So now we know we have an application which actually connects to Postgres database, and it actually connects to Redis database. These two Redis database and Postgres database are exposed with name DB, and it is exposed with the name Redis, right? Remember this. This is exposed with name Redis, and this is exposed with name DB. So these DB and Redis, these names you get it from the YML JSON value. So here in the JSON docker.aws.json, you have the names here. So the name DB, the name is Redis. You are exposing this Redis. What is the definition of this Redis? It will actually copy this particular image, Redis image, from Docker Hub. So if you go to Docker Hub Redis, you can see that here. Just go to Docker Hub. You can search for Redis. So this is what Redis is, right? So it will actually pull from this particular Docker, this image from Redis Docker Hub with the tag as mentioned here. So the tag is mentioned as 6.0.8, right? Redis 6.0.8. That you can actually see it from Docker Hub. So there should be 6.0.8, something like this, right? So this is what you have different many tags here. You are actually pulling one tag with name 6.0.8, right? 6.0.8. So that is what you are going to pull from Docker Hub, which is already there. You will just pull that particular Redis image from Docker Hub, okay? And it will build a container from this location. So it already has Docker Hub access. It is a public repo. It will pull the container from the Docker Hub and create a container for us. And similarly, this one also, it will actually pull DB for DB. It will actually pull the image from Postgres from Docker Hub. So if you see the image Postgres with tall Alpine, so it should also be there in Docker Hub. So just go to Docker Hub. Search for Postgres. So we have Postgres container also in Docker Hub. So it will pull the Docker Hub Postgres with the mentioned tag tall Alpine. So it will pull that particular tall Alpine from Docker Hub. So this is already there. Tall.alpine is already there. So this will pull this particular tag tall Alpine Docker Hub values. It will pull it. Okay, this tag it will pull and it will create a container. So you have one container. This is Redis container. It is going to build from Docker Hub, and it is going to build a Postgres container from Docker Hub, and it is going to configure it with environment variables and so on. And after that, it will build our web application from this particular Docker Hub. So it is not yet there. Anil, but B user wishlist is the Docker Hub container that I am going to build. That I am going to build with the help of travis.yml. That you can see in the travis.yml, I am clearly mentioning that I want Anil but be user wishlist app. This is the app I'm going to build using after success. After success, it will push to user wishlist.yml. So overall, just briefly explaining what at the end of the day, what we actually need for the entire application to be deployable to Elastic Beanstalk is this travis.yml. We need this travis.yml, and to deploy to Elastic Beanstalk only, Elastic Beanstalk understands this file, docker run aws.json. So we need these two files to deploy to Elastic Beanstalk, and we are going to deploy multiple containers, right? So let's do a quick commit. Let's do some commit to this. Let's make a small change somewhere. Okay, let's make a commit. Let's do an online commit. We all know how to use Docker or GitHub, right? So I'll not go to the terminal and do these things. I'll just do it here. So I'm making a simple change. Users wishlist. I'm going to commit it, and I hope it works. So I just do a commit now. After commit, you can see that travis.yml will pick the commit and it will start the build. Because we already configured the travis.yml, we should be able to see the travis.yml. Go to dashboard. In the dashboard, okay, I didn't explain few things what we configured in travis.yml, right? So in travis.yml, we already configured the repo. So the repo should be configured. Where is the repo? The repo is user wishlist tab. So this is the user wishlist tab which I already configured. How to configure this? Go to github.com. You can just go to github.com and go to your settings here. Settings, and here in the application, you should be having Travis DI integrated. Application should be already be integrated, and here you have to make sure that your repo is added to Travis. So I have already added few repos to Travis, out of which user wishlist is one of the repo. Okay, so now go to this particular, see you have already configured user wishlist app as a part of Travis repo. You have permitted Travis to access this particular repo user wishlist app. So you can actually see the Travis in the Travis dashboard. You can see our user wishlist already added. This is user wishlist. So just click on this particular repo and you can see that build history. By clicking on the build history, you can see what commits are going on now. So already I have few commits. Now I will do another commit. So let's do a commit. So I am trying to do a commit. So for namesake, for understanding purpose, I did a small change here and I'm going to commit it here. So I'll do a commit. I'll say commit. Yeah, updating index. Index.html. So this is the commit I'm doing to main branch, right? So I'm doing commit. So done. So I did a commit now. And by doing this commit, automatically, because I have a travis.yml here, travis.yml will pick up and start executing all these things. That one you can actually see it here. Now, see, you can see that already the build has picked up. By doing a commit here, by doing a commit and push here in the GitHub, you can see that travis.yml has picked it. You can see the commit message. Just now I have committed with this particular name, updating index.html, and it Travis picked up that particular commit. And you can go into that particular job, commit job, and see what is going on. Okay. So the job got started. So just let me make sure that I have everything built. So this is the travis.yml, and I should be having a bucket with name my first bucket in AWS, and bucket path there should be Docker. Let me make sure that these are there. If they are not there, and everything will break. So go to AWS console. We can go to AWS console. Okay. S3. what was the name of the bucket? My first app bucket, right? So go to that particular bucket. S3. So do you have my first app bucket? Okay, so we have a bucket called my first app already. Okay. Let me refresh it. It's asking for password. I am entering my AWS console password. No, I have already this bucket. I have this particular Docker, so everything should be going fine. So I can see in my Travis what is the status going on, right? So the build is going on. The build is completely successful. Okay. So the build is successful. It actually started deploying. So what? Let's go to this travis.yml. So after successful build, it should actually push to it should push the container to Docker Hub, right? So now, as I said, the Docker Hub didn't have this particular image user wishlist app. Now it should be having. So I will go to the Docker Hub now. So here, so I will go to my Docker Hub home page. See, so this user wishlist is created just now because of the deployment via Travis. It actually created. You remember I deleted it, but now it is again created the user wishlist image. So this user wishlist has just been created. It was pushed 1 minute ago. So according to this Travis, it actually pushed this particular image to Docker Hub. So this happened, and after that it started deploying to Elastic Beanstalk. So once I said Elastic Beanstalk, it will go to if it will look for if it already found out that it has Docker run aws.json file, and it will deploy all these things into Elastic Beanstalk. So Elastic Beanstalk should actually have this latest deployment in our app. So if you remember, our basic Elastic Beanstalk had this page, right? This was the page which was by default. But after we did a git push commit, we did a git commit, this will be redeployed with our application. So this is our application. I just refreshed it. You can see that our application got deployed here. So this is the application. Okay. Now our Elastic Beanstalk successfully got deployed into our environment called My First App environment. And this is My First App. When I click on this particular URL, this is what I have seen. This is my web application which is running now. Now you can actually work on it. So you have application which actually should be able to store the information whatever you enter here. I am entering a particular username admin. My favorite place Bangalore, my favorite food, I'll say Italy. So this is what I am going to enter. So I'll click on save. It should actually store all this information into database. So successfully you are able to store the details into the database. This is how it is getting stored. So again, if you want to retrieve the information from the database, you enter the admin and you can see that, okay, so you actually retrieved it from the database, Redis database, and you whatever you entered before, you are able to get it from the database. Admin is it's wish list for admins Bangalore and Italy. So this is what you are able to retrieve it from successfully from DB and Redis database. So your entire application is running. So once you have configured everything, all you need to do is a simple GitHub push. Okay. So you remember what is the push I did? Users. This is what I did, right? I modified user to users. This is the only change I did. Okay. And it got reflected here in the application. So let me say I will name it like users. Not this is I will put my name. I'll say Anil's users wish list. Okay. So let's do it once again so that you can just get a feel of how it is easy to deploy all your changes by a single commit. So you just go to user wish list. You want to change your application. You want to change your application index.html, and here it was users wish list. You want to change it. So let's change it. I will make it like I'll say it Anil users wish list. Okay. So I'm going to push it. I just do a commit. Make Anil to heading. So this is what I'm doing. I am adding Anil to heading. So that's what I'm doing. I'm just adding Anil to the heading, right? So this is the commit I'm trying to do. Adding Anil to heading. So I just do a push. Now I am pushing to GitHub, and it is very simple. Now it will just deploy this particular changes to our Elastic Beanstalk. So as soon as I did a commit, automatically Travis build will start. So this Travis build was updating index.html, but latest thing you will get again from here. So it is build number 7. So it already started deploying the latest one update. Build history. Okay, I did I put a different commit? I think I did a different commit. I'm not sure. Okay. Anyway, I did a commit with name updating users, na? Okay. Okay, it actually started with the old commit name. Maybe I typed it in the description. Okay, okay. So I typed the text in a wrong place actually. So the commit has picked up with a different name, but it is the second build. The build is going on. After the build is successful, the build is successful. After the build is successful, it will it will actually reflect back in our web page here. So after the build is successful, you can see the build here. So you can see that environment build is going on. Okay. Now it will take some time. So it is Anil's user wishlist. That is what you have to see now. Yeah. So the deployment is done. Now by doing a commit in the GitHub repo, you can see that our deployment, the whole deployment has happened, and it got deployed here, and the latest changes got updated here. So you can see that you can see that the latest changes are there in our application. So application is running the latest commits. So this is how multi-container application has we got it working. Okay. So just let me know if you have any questions. So we have seen how we can actually do a multi-container deployment. You can actually go through these steps offline also. So we have this repo. Feel free to ask any questions if you have. So we have seen an example of how to do a multi-container deployment. So basically now you have 3 containers in this particular application. In this particular application, Elastic Beanstalk application. In our Elastic Beanstalk application, you can see that we have 3 containers running in the single Elastic Beanstalk application. Okay. I'm doing some cleanup. There are a lot of pages. I'm just Okay. Yeah. So we have seen how to do a multi-container deployment using Elastic Beanstalk. Our latest commit, how it is going, how it is just um, getting deployed by a single GitHub commit. We are actually deploying 3 containers in this particular environment. My first app environment contains three containers. So it is as simple as that. So what if you don't want multi-container application, but you want to use external databases? Like you don't want the database as a container, but if you want to deploy a separate database in AWS, you want to deploy a separate Redis database in AWS. Okay, you want to deploy them separately. What is the steps? You want to have a single container deployment which takes other databases from external sources. Instead of a container database, you want a real AWS based relational database services to be used. What if I want to do that? So that is what we are going to discuss now. So our next topic is topic 11. So that is what we are going to discuss now. So this is the topic about how to deploy a single container Flask application with external data, external services like AWS RDS, AWS Elastic Cache. So if you want to connect your application with external services of AWS, how to do that? So this is what we are going to do. So here we are just going to use Travis AI help. We are taking help with Travis AI, and we are going to connect with AWS relational database and AWS Elastic Cache. We are going to connect all those 3 of them. So instead of having a containerized RDS, instead of having a containerized Elastic Cache, we are going to have a external relational database, external Elastic Cache, and deploying it as a whole. So that is what we are going to learn now. So we need to create a external relational database, external Elastic Cache, right? And we have to create all of them in a single virtual VPC environment. So that is what we are going to learn right now. Okay. Okay. So we'll go through it step by step. So let me know if you're following up. So we have to go to Redis now. Now AWS, we have to create the services. Okay. So step by step, like there are simple steps. Let me go through the slides once again, and then we will actually do it practically. Okay. So this is the steps which explains how to connect to Redis database. So first we have to deploy this video actually explains how to deploy a Flask application with AWS and RDS. Okay, and how we can use how do we set up our security group, and how to make the networking concept that we have used in Docker Compose, the similar kind of environment, how can we enable it using security groups? So that is the second slide about. So how are we going to create a separate security group? So those security group steps, how to launch Elastic Beanstalk, we already seen. We will do the same thing here. How are we going to launch application with Elastic Beanstalk? Then the fourth step is how to create a security group for Redis, and how to create a security group for Elastic Cache. And then later we will see how do we launch a Redis Elastic Cache, and how do we configure the security group to Elastic Beans. And then we'll push the code to GitHub and see how it goes. So these are all the steps we are going to follow. So for this, I have already created a repo. Okay, so in our repo, if you see, we have a different branch. So let's go with the slide. So here we have a repo. We have a repo here in single container app. So this is what the repo is. Okay, so it is there in CloudX Lab. It's a public repo. You can go through it. So it's a branch of the same user wish list. So you can just switch to the branch here. So you can just switch to the branch, AWS branch, AWS cache redis repo, and you can see the source code here. Okay, though it is exactly the same of multi-container application, but you don't have a uh, Docker compose dot docker.json. So like it is not a multi-container application, so you don't need docker run.aws.json. All you need is a single Docker file, and this Docker file will be having code to copy this application, and application will be using the external services. That's what we are going to do here. So we are going to have a AWS cache EB branch. Here we look into the code. Here, if you see that the code is actually directly contacting via environment variables. In the previous example, we have seen that we have hard coded the username password, but in this case, you can see that we are having environment variables, and we are going to define all these environment variables inside the Elastic Beanstalk environment. Okay, so and our application will pick those environment variables from the Elastic Beanstalk environment. Okay, so these are all things we are going to populate. So these are Postgres related environment variables. These 5 variables are Postgres related environment variables, and these 2 are Redis related environment variables. Okay, now first, as a first step, as per the slides that we are going to follow, I think we can actually create security groups. Okay, so security groups we are trying to create. We'll try to create security groups. How do we create security groups? We will see. So how to create security group? We'll see here. And after that, how do we launch RDS? How do we launch Elastic Cache? We'll see here. How will we connect RDS Elastic Cache with the Elastic Beans? We'll see that step by step. So we are trying to follow this video. Practically, we are going to implement them. Okay. So before that, let me create an environment variable, Elastic application. Let me see if I can reuse the existing environment and Elastic Beanstalk application. So here, let me go to AWS. So my Elastic Beanstalk, this one is it is a ECS kind of. Let me delete it. So because I remember I created this application as a ECS kind of application, right? So because I am deploying a single container application, I don't want it. So I will delete this. Okay, so it will take some time to delete. So I'm going to delete this application. I will start from scratch. Okay. So let me confirm what is the kind of environment variable I actually need. So let me go to my web page. So let me go to my GitHub repo for Elastic Beanstalk. Yeah, so this one. And I will go to travis.yml. What is the kind of environment variable I want to, what is the kind of EBS name application I want to create? So, okay, so the EBS application name is same. I want to create a application with name my first app. So I will just create I will create a application, Elastic Beanstalk application now. So I will wait for this all applications to get deleted. It will take some time. After the application gets deleted, I will create a new application. So let's wait for some time. Let's go step by step. Let's wait for a few minutes. It should get deleted. Okay, it is getting deleted. Okay, it is taking some time. So let it get deleted. Meanwhile, we can actually create a RDBMS, relational database. Before that, we can actually create security groups also. Let's go step by step. Um, how will you go? How will you go to security groups? So we are going to create security groups in a service called VPC. So we have a service called VPC. So here in the VPC, we have something called security groups. Okay, so we can create our own security group. Did I create now? Yeah. So I already created few security groups. So this is my security, my Redis security group. For DB, I have created security group. Let me delete all of them. Let me create from scratch. Okay, so I have deleted those two security groups. Let me create a security group now. So I will create a security group for database. I will create a security group for Redis. So I will say my DB. I'll create a security group for DB. So I will use the default VPC. This is the default VPC. It is actually recommending. So I'm just going with the default VPC because I have already created a Elastic Beanstalk inside this VPC only. So it is in the same local VPC environment. I'm going to create the security group also. Now I'm just going with the security group with name MyDB security group, and that's it. I should be able to create the group, right? So, and I will attach inbound rules also. So I created a security group and I will attach inbound rules. I'll create a rule. I don't, for the DB, I think it is 5432 is the port number. Postgres default port number is 5432, and I am going to attach it to my security group. My DB security group should be there. So this is I am attaching this inbound rule to my DB security group. I'm attaching this group. So I should be able to access the security group will be attached to Elastic Beans so that Elastic Beans will be able to access this particular security group, which exposes the port 543. So I am storing this security group. I am going to create another security group now. Now I have exposed Postgres security group. Similarly, I'll go to security group section and I will create another security group. I will I will name it as Redis security group. So I'm naming it as Redis security group, and I'm storing that. I'm creating a security group with that name, and I'm editing inbound rules. What is the default port of Redis? So Redis default port is 6379. So I am going to attach inbound rule of Redis add rule with port number 6379, and I am attaching it to my security group Redis, and I'm saving this rule. So I have created two security groups. So this one security group is for the database and the security group is for the Redis. So I'm creating two security groups. Now I have to create database. I have to create a Redis. So to create database, we have to create Postgres kind of database. So in AWS, we have a service called RDS. So we'll go to RDS. Okay, we'll go to RDS. Meanwhile, let's see if our application got started or not. Where was that? Okay, let's go there. Let's go Elastic Beanstalk. So we have started an application, right? Elastic Beanstalk. So let's see. Yeah, so we deleted the old applications, right? So now our Elastic Beanstalk is completely empty. It has no applications. The applications are empty. So now we can create a Elastic Beanstalk. We are free to create an application. So let me create an application here. Let me put the name, same first name, my first name, because in my travis.iml, I have already said that my Elastic VS Elastic Beanstalk application name is my first app. So I am going to create the same thing here. My first app I'm going to create. I'm choosing it as a Docker, and I don't want to create ECS. ECS is Elastic Container, means a multi-container application. Instead, I will go for a single container Docker kind of and branch I'm going to create. So I am selecting Docker running on 64-bit Amazon Linux 2 kind of branch I'm creating, and I'm just creating the application. So I have started creating application of Elastic Beanstalk with name my first app. So it will take some time. Let it go. Let it happen. So let this particular environment for the Elastic Beanstalk be going on parallelly. We will try to create a we'll try to create RDS, relational data service. So we are trying to create a Postgres database in Amazon. So I will go to RDS service, relational database service. So we can just go to relational database service, go to DB instances. Right now we don't have any DB instances. So I'll go ahead and create a database. So go and create a database. For our application, we are trying to create a Postgres kind of database, right? So if you look into our source code, in our source code, we are having code to actually connect to Postgres. So this is all Postgres that we are going to use, right? So we want a Postgres kind of database be available. So I am trying to create a Postgres kind of database. So here we have Postgres database. Okay. So I will just select this Postgres database and don't go for production. I'll just go for free tier. I'll just go for free tier and let me put it as Postgres DB. I'll put the name as Postgres DB. Okay, and it is asking for putting a username. So for now, I'll put the username as Postgres only, and for the sake of simplicity, I will actually put the password also as Postgres only. So I'm entering the username password using which we can actually connect. So this username and password, we have to send it as environment variable. If you remember in our source code, everything is an environment variable. So somehow we have to get those environment variables. We have to initialize these variables. These are variables. Postgres user, Postgres password. Now you have to remember what you are creating it. So in RDS, we are creating a username called Postgres, right? So that we have to enter in this environment variable Postgres user, and the password whatever we are going to create now, which we have entered here, we have to put that environment variable also. So I am creating username, password, and okay, so I'm going to create a DB. Let's make sure that we have a smallest configuration. Okay, it is the smallest configuration only. Or do I have more small? No, this is the smallest of things. So we will just create and immediately delete it so that we don't get charged. So AWS will charge us if we keep on using the database for long time. So as soon as we create a DBs, we complete our learning, we will just delete the database. Now I am entering other configurations. So let's go for basic configuration. Auto scaling, I don't want for just for demo purpose. I just don't want all these extra features. Um, Okay, general purpose, availability zone. So auto scaling anyway I have removed. I have removed availability and durability also I have removed. I just want a basic simple database. So you remember this is the VPC that I'm creating. So it is under default subnet. This is the VPC security group. Security group. You remember we have created a security group for database, right? So here we'll try to add our database security group. So this is what security group I have created. MyDB security group I have created. I will add it. So I added MyDB security group, which exposes the port 5432. So I have added this MyDB security group here, and yeah, so all we'll keep all other as default. So yes, I'm going with password authentication. Um, yeah, though turn on performance insights, I don't want now. For now, we can add it if you want later. For now, I don't want anything. Additional configurations. Let's look into it. What we can have. Initial database. Okay, so let's name it as Postgres DB only. The name of the database. Remember it. This should be as a environment variable. The database name I'm putting is as Postgres DB. I will remember it. Future I will initialize all these environment variables. Database I have put backup. Do I need backup? I really don't need backup. I can just remove it. Enable encryption. Let's keep it as it is. Let's just, I'm trying to make sure that I have minimal configuration. I'm reviewing auto minor version upgrade. I'm removing it on it. So this is what I am going to use as a database. So I am trying to create a Postgres database now. So this Postgres database, I will create, just create it. So I created Postgres database now. It will take some time to initialize. Now currently it is in the status, creating status. After some time it will be running state. It will be in available state. So once it is available, we are good to go. So we have created a Postgres database now. So let's wait for the database to come online. It should be available state. It should be in available state. Meanwhile, let's see how it is in our application, how it is going. So application is still is in running state, is starting state. I think it's done. Let's refresh and see. Okay, it is not yet running. Oh, so we wanted to create my first ENV environment, but somehow it got created with environment my first ENV1. Okay, no issues. So we can delete it. How to Okay, I had to wait some more time to for the environment to get deleted, but before that only I started a new application. Because of that, it created environment with name my first env1. So what I will do is I will actually make the environment as my first env instead of my first env. So this one I can just go and make sure that it is running. Okay, it is running. So this is running. So my first env1 is running, right? So here in my user in my deployment in my travis.yml, instead of my environment name was supposed to be my first env. Instead of that, now it is my first env_1. So I'll just change it to my first env1. So I'm going to make a change like my first env1 because my environment is my first env1. Okay. And now I have my Postgres running. Postgres DB is already still in creating state. Let me make sure that it is in available state. Yep. So my Postgres DB is in available state. And later, now next step is I will have to create my Redis Redis database. So Redis database in AWS is Elastic Cache. I will go to Elastic Cache. So I'll try to create an Elastic Cache. So Elastic Cache, let's see if I have anything already there. So I'm going to create a Redis cluster. Yep, so I have nothing now. I will create a Redis cluster. So I will configure a Redis cluster. I want to make a basic Redis cluster. I don't want the enhanced features of Redis. So I have disabled the cluster mode. I make a simple Redis cluster. So the Redis cluster, I will name it as my Redis. Okay, I'm going to create my Redis. Okay, it is complaining. I send my Redis and description also same thing. My Redis. Multi-agent I don't want. Auto failover for now I don't want that also. Let's see. Yeah. So default Redis. It is saying large. Let's go for small. If I have small. Yeah, there is something called micro. Okay, I am going with a very minimal configuration. I just want cache T2 micro. So I'm just creating T2 micro. Number of replicas means number of replications. No, I don't want any replicas. Only 0 replicas. I'm creating a basic Redis service. Uh, yeah, subnet group, availability zone. Nothing is there. Okay, I'm good to go. I just go to next. Selected security group. Okay, so security group. It is saying what security group do you want to add. So maybe like I can add my security group, which is I have created my Redis security group. I am going to add that particular my Redis security group. Choose it and let's keep other things as let's not auto upgrade, auto backup not required. Okay, so we are going to create a Redis cluster, basic minimal Redis database we are going to create. Now, let's say create. Yeah, so I have created database, I have created my Redis. Now I have two services ready and I have to connect these two services with my Elastic Beanstalk deployment. Okay, so let it go. Now I will go to my Elastic Beanstalk. Uh, so this is my Elastic Beanstalk, right? So this is my environment. I'll click on this particular environment, and I will attach. Uh, Go to the left side. You have configuration for your environment. So this is the configuration for your environment, and you want to attach your security group. So maybe it is there in the instance. So there is edit section. Go to this edit section. You can see security groups, right? So you already have, you should be able to connect to your database. So you have to check in my DB security group. You should be able to connect to the Redis security group, Redis database also. So I will check this also. So this will help us in connecting to Redis database and MyDB. This is Postgres DB and Redis DB. So to connect to both this DB, I just check these two so that my Elastic Beanstalk deployment can have access to them. So I'll just put apply. Okay, so it is saying that changes will not take immediately. It will each of your EC2 instances will be replaced or new settings will take effect then afterwards. Okay, so it will take some time. That's what it's saying. Let's click on the confirm. So by this, it is actually changing the configuration of my Elastic deployment environment. So it is attaching the new two security groups. So it will take some time to actually attach those security groups. So we have configured to connect to the ports via security groups. Now we have connected ports. Next thing is like we have to connect. We have to find a way to. Um, we have to find a way to actually show. Okay, let me commit it this first. This one I'll commit. We should be able to put the environment variables also, which is there in our code, right? In our code, we already mentioned a few environment variables. Those environment variables should be entered into our Elastic Beanstalk deployment environment. So these are variables like Postgres user, password. These we need to give it in our Elastic Beanstalk. Okay. So let me do this commit. So because we are relying on the new environment 21, I'll just commit it for now. Okay, we will ignore the auto builds that has happened, but for now, um, uh, we will wait for our environment variables to get configured. So it is getting updated. It will take some time. Let us wait for some time to the environment get updated. Okay, it's taking some time. So in our application version, we have only one application, sample application. Let's wait. Okay, so my application environment, okay, it is still updating. Let's wait for some time for the environment to come up. Okay, so our environment is up now. So what we did is we set up the security groups. Our next step is to actually set up the environment variables. So we'll go back to our environment, which is first step environment one. So here in the environment one, go to configuration back. And here in the software section, here we can enter our environment variables. So these are environment properties, right? So we have set of properties that we need to initialize. Postgres user, Postgres password, these are all the variables we need to initialize. Okay, so let's initialize one by one. Meanwhile, our Redis database is also ready. You can see that our Redis database is ready here. Postgres user, you know what is the name we put is Postgres. We just put the Postgres user as Postgres. Next we'll put Postgres password. That is also we put it as Postgres only. Next is Postgres DB. This DB, I think I put Postgres, my Postgres DB, right? Let me confirm. Let me go to the RDS service. So in the RDS service, I will go to the port. So my DB name is Postgres DB. This is DB identifier, but actual DB name we will get it in the configuration. So DB instance is Postgres DB, Postgres DB. So this is what you have to enter here. So DB name is not my Postgres DB, it is Postgres DB. Okay, so Postgres DB is over. Now next is Postgres host. So Postgres host is, you will get it uh, from the URL, right? Yeah, so this is the endpoint. So public endpoint, let me confirm. Yeah. So postgresdb.com. Yeah, so this is the endpoint that you have to enter in host name. So you just enter Postgres host name and then port is 5432, right? So these are the environment variable for Postgres. So next environment variable that you need to initialize is Redis specific environment variables. So Redis environment variables is Redis host and Redis port. These two values you need to enter. So those two values, Redis port and Redis host, right? So you have to go to our Redis Elastic Cache. You have created a Redis instance, right? So go to Redis cluster. Here you are already created your Redis. So your Redis and Redis host. So this is your primary endpoint of Redis host. So just copy this Redis host in this Redis host, right? Redis host. Enter the endpoint. This is your endpoint for Redis host. Then Redis port. For Redis port, you have to enter the port which the Redis exposes, which is 6379. Okay, so here you don't want to have this one, and Redis port is 6379. 6379. Okay, so you have initialized 1, 2, 3, 4, 5, 6, 7, 8, 7 environment variables in your environment with name my first app env1. So you will get it in your OS environment, all these values. So just click on apply. So I think I have not done any typo error. Everything should go as perfect. So with this, we are ready with, we should be able to connect to Redis database and to the Postgres database. It should work as expected. Okay. So let's see other configurations. So other configurations are like in our edb travis.yml, we should be having a bucket named AWS class Redis November 27. This is what I put the name. So let me make sure that I have that particular S3 bucket. So I will go to the S3 service. Go to the S3 service, make sure that we have the bucket with name. Okay, so we already have this bucket with name this one, right? So we are good with that also. Now we have S3 bucket name. We have AWS access key should be there. I think I already configured it. We have to configure all the Travis YML specific variables in Travis settings. So these variables, AWS access key, AWS secret key, we have to go to Travis. Where is Travis? We have to go to Travis. Okay, so go to Travis here. This is something wrong happened. Let's look into it later. Something wrong. Okay, so let's ignore this. We just speedily did that. So here in Travis settings, we need to make sure that the environment variables are there. We already have AWS access key, AWS secret key. These two variables are only sufficient. So we already set it with our user account credentials. We just filled that. So we are good. We are good with these variables also. AWS access key, AWS security, we are good. Now we just need to make some deployment. I think we are good to go to have a deployment. Let's do a small change somewhere. So let's go to our. So we are creating. We are doing a commit again. Let's make a small change. This is user wish list. Okay. Now, as a my first AWS Redis / Postgres services. I'm using these two services. Postgres Redis better is I will say AWS RDS / Elastic Cache commit. Okay, test. I'll say this is my first AWS Redis and Elastic Cache test. I'm going to commit it. So I am pushing these changes. This push should actually go, and it should be picked up by my Travis. So I'll go to user wish list, a build history. Okay, so this is what my new commit has been picked up by Travis. The Travis has picked up my new changes now. Now the job got started. The build job has got started. Now it is a simple build. It should actually build the Docker, and it should actually deploy it in my Docker Elastic Beanstalk service. It should actually deploy there, as mentioned in my travis.yml. So here in my travis.yml, I have mentioned that I have to deploy it in Elastic Beanstalk with app, my first app, my first app env1, right? So I will go to my first app env1. So I can see that environment deployment seems like it went through successfully. Let me verify that. No, it still didn't go. Okay, it is still updating the environment. Let's see if my Travis build came up. Yeah, my Travis build came up here. So from my sample application, the latest deployment is Travis with this specific number. So my commit is there here. This commit, I have already committed my first AWS Redis Elastic Cache test. So that is what I am doing. And typically after successful deployment, it should actually update. So it says the environment is up now. No, not yet up. So it is still doing some health check. So hopefully I did all the configurations perfectly. So if everything goes perfect, all the environments are all the environment variables and security groups, everything are working fine. My Elastic Beanstalk application should be able to connect to my RDS and Elastic Cache. So I have created my RDS here. It should be able to connect to my Postgres DB, which I have created, and my Redis endpoint which I have created. All those things should be working fine. So let us wait for the environment to get updated. Hopefully it should be in a healthy state. So if it is in healthy state, I should see a green signal here. After everything is okay, I should be able to see a green signal, and I should be able to deploy. Otherwise, I have to wait for some time for. Otherwise, I have to probably do some debugging if it is not fine. I hope it is working. It should work fine. Let's wait. So it is still deploying. My environment is still trying to deploy. It is taking a lot of time. Let's wait. So meanwhile, if you have any questions, just shoot questions to me. We can have a discussion. So I hope you are all understanding what I'm doing now. Okay, now it says it is healthy. Let's see by opening the application URL. Okay, so the deployment went good. Okay, so the latest commit is like I committed these changes, right? This is user wishlist app. So my latest commit got deployed here, and I should be able to be successfully connect to the database, right? So, so everything seems to be fine. Let's see. I try to store those values. Okay, it is successfully able to connect to the database, Redis database, and if I retrieve, I am able to retrieve. Okay, all good. So we are able to successfully connect to our Redis database. So we have created database in Amazon RDS service. We have created a database Postgres DB. So here we have created a Postgres DB. We have created another service called Elastic Cache. Elastic Cache. So we created an Elastic Cache. We created a Redis basic Redis cluster, and we created two services finally. One is the um, database RDS database with name Postgres, and Elastic Cache Redis Elastic Cache cluster with name MyRedis. So these two things we were able to do, and we were able to deploy and connect to these two services via my Docker application in Elastic Beanstalk. And we are able to store. Let's say like I want to enter another thing. I want to enter Shankar. Shankar, I think he's from Chennai. Let's say his favorite is dosa. So I just enter these values. So I'm able to enter uh, Shankar's favorite place and Shankar favorite food as Chennai and dosa, and I'm able to retrieve that also. So I am able to trying to retrieve. I am able to retrieve Shankar's specific information, Shankar and Chennai. So if you want to know how this particular application works, so it's a basic Flask application. You can just go to the source code here. It contains the basic app.yml main.py and the basic template of showing what to show the forms and how how to enter different values here. You can just see, and so this is the working model of the application which we are deployed in Elastic Beanstalk. Okay, so with this we have covered two topics, topic 11 and topic 12, a multi-container deployment, Docker deployment, which is having three containers, the web application, Python-based Flask web application, Redis container, and Postgres container. In the second topic, we have discussed about a single container deployment with external AWS services connectivity. We created a AWS RDS service with Postgres database and AWS Elastic Cache service with Redis database. So we are able to connect these two databases with our application in and deploy it in Elastic Beanstalk. So by a single commit, we are able to deploy end to end in Elastic Beanstalk and able to connect to that particular services in AWS. You got it right? So it's as simple as you just need to commit and we are able to make a small change and that changes will be reflected in our database, our Elastic Beanstalk application. It will be, let's do another small change. Let's make sure that, let's revert it. Let's make sure that I will remove this. So my second test. Okay. Now, after the deployment happens, I should be able to see the new heading user wish list here. It should be as simple as that. So by single commit, everything gets deployed in our production. So it just gets reflected into our production and you can see the changes here. I just removed this is, right? So those changes will be reflected in our production within few minutes. Let's wait for it. So we can just see how the status, what is the status now? The build might be started. Go to the build history. Now this, my second test got started. The Travis picked up my latest changes. It is started the build now. Now it is building. Okay. So now it is building. My Travis is actually building the new changes. Okay, and it's actually after successful build. Okay, so it is green mark, right? So the build seems to be successful. Let's close this. Let's go to our Elastic Beanstalk and let's refresh what is happening here. Okay, so it seems like my changes have come up. Okay, so the new build has picked up. So this is actually which are whatever changes I did in the GitHub got reflected and new changes are there in my deployed in my production. Okay, so just let me know if you want to discuss anything more. So more interestingly, we can actually see, we have seen all the Travis working with AWS services, right? We have seen a lot of services in AWS, how it is working and so on, right? So we can do the same thing for Azure. I also worked on Azure services now. I was able to successfully deploy into AWS also. So I have a small commit. So let's do that also now. Okay. So let's switch from AWS a bit. Let's move to Azure services also. So I'll give a few. I will introduce a few services of Azure also now. So I already experimented on few services. I'll just show you what I did. So we have in Azure we have something called web apps. So what we have like similar thing is similar to AWS Elastic Beanstalk. Here in Azure we have something called Azure web apps. So we are going to deploy our changes in our GitHub. Whatever we do in our GitHub, we are going to deploy it in our Azure web apps. Okay. So while doing what are the steps we followed to deploy into Azure Web Apps? We'll just have a look. It's also very simple. All we need to do is like spend some time, try to understand what is going on, how the Azure how does Azure services work, how to store them. We need to just have a learning and we are good to go. So I'll just show you a brief step by step of how to make a Azure deployment. Okay, so I have a source code. I'll close this. We are done with AWS. Okay, now let's switch to AWS Azure. So this one I just tried out and it is successfully running now. So I have a uh, GitHub repo with travis.yml, which I have configured it for Azure. Okay, so let me go to my GitHub. So let me switch from Azure from AWS. I will give you my repo. Okay, so this is what I have. So I have created this Git repo to demo about Azure Web Services. Okay, so here in this example, similar to AWS, I am going to deploy it in Azure. So in Azure, in Web Apps, I am going to deploy. So in this process, we will come across multiple resources. One is Azure Container Registry. So I'm going to use Azure Container Registry along with Azure Web Apps and Azure Service Principles. I will use these three things and configure these three things, and I should be able to uh, do a runtime deployment within few minutes after every Git push. So that is what I'm going to show you now. Okay. So let's go to it. I'll just share with you with all my changes with my repo. You just follow these steps and you should be good to go. Okay. So I just paste it because it is missing. It is not there. This particular section is not there in in our slides. So here in CloudX Lab, we don't have all these. Everything we have is Amazon AWS services only. This particular demonstration is extra, which I am going to explain. Probably you try it of your own. If you are you already have Azure account, you can just try it with this particular instructions. So I am going to post it here, and maybe I will post it in my WhatsApp group also. So I'll just post it in my WhatsApp group also. How to do that parallel? Give me some time. I'll just post it in our WhatsApp group. So you can see the Travis CA mails also coming up. So you can see that what are the mails. So if it is successful, if it is failed, we can see mails also. So the Travis configuration is pretty simple. Okay, so I have posted it in our group. WhatsApp group. Just have a look into that. I'll quickly do a running demo of that particular um, steps to actually do the deployment. So I will log in. I will log into my Azure account. So I am logging into my Azure account now. So I think I am already logged in. Let me close others. Okay. So we have so like so in Microsoft Azure, right? In Microsoft Azure, so we can have multiple services similar to AWS services. We have many services actually. So out of which today we are going to actually come across a few services. One is like the app services. This is app services that we are going to use, and the services which is called Azure Container Registry Service. So we are going to use two services actually. So I already did something. I can actually redo the same thing. So we'll actually create multiple services. We'll group all the services into a single resource group. So yeah, so it is very convenient to actually club all the resources into a single group. So that's what we are trying to do. Okay. So what we'll do is like we'll just create a resource group first of all. So go to resource group. Go to resource group. We'll just create a resource group. So here I will create a resource group. I'll say that my my test resource group 2. Okay. So let me name the group as resource group. Basically, what is resource group is like we can create many services. All the services can be grouped together in a single place. So that is called resource group. So I am just creating a resource group, my test resource group here, with name my test resource group, and I am going to create it now. So I am creating it defaultly in US East zone for now. Just creating that. So validation is passed. I just created. So I have created a resource group, and in this case, you just need to follow the steps which is already mentioned in our GitHub. So next step is like I will create a container registry. I will create a web application, my web application. So I did the same thing actually already before. I can just show you that. So here in our repo, right? In our repo, if you go to our repo, let's close all AWS things. So in our repo container template here, the steps are clearly mentioned. You need to follow the steps. So basically, we here I have recommended to use Azure CLI. We will go with Azure Portal Console UI. We just do it via Console UI. Same thing you can do it in Azure CLI also. Okay. So so you have to first step is like you have to create some resource group, and after that you have to create a container registry. So container registry is basically a service which is Azure way of creating it is similar to Docker Hub. It is Azure way of storing images. So Docker Hub comes for free, but Azure Container Registry is a commercial service. It actually charges for the images that you are going to store. So we can create our own container registry, and we can actually upload all the images in our Azure Container Registry. So we have to go and create a container registry. After we create a container registry, we will be actually creating another service which is called Azure App Service. Okay, so we will be creating a Azure App Service where we will be actually deploying our Docker application. Our Docker application, which is actually similar to what we call Elastic Beanstalk in AWS. Okay, so we'll create a Azure App Service, and later we will we will actually have a web application for containers deployed in it, and then we'll create a service principal which is basic, which acts as a programmatic user, which will help us to deploy it in our production. Okay, so those steps are pretty much clearly mentioned here in these steps, right? So we will go through these steps one by one, right? So this is a CLI way. You can actually download the Azure CLI and actually run this application here, or you can create it via UI. So I am just going to create it via UI. Just now I created a resource group, right? So I have created a resource group with name my test resource 2, right? So that's what I did. So next I will actually create a container registry. So next step is to actually create um, a container registry, Azure container registry. So to do that, I will just go to my resource, newly created resources where I have created. I will go to resource groups and I will go to my resource group, test resource group here. And in my resource groups, I'll click on create, plus create. And here I will be directed to marketplace where I can search for container registry. So this is a Azure service. I will just go to container registry and I will create my own container registry. By clicking on this click, I should be able to create container registry. So I have to follow the steps of container creating registry. I'll just follow the steps. Okay. So I'll give the registry name, location. By now, for now, I'm defaulting everything to East US. Okay. So I'll create a container registry, review and create, and I should be able to create a Azure container registry. So I have already done that. So I don't want to redo the same thing again. So basically, by following these steps, you should be able to create a container registry. Then after as per the steps, after creating container registry, right? Make sure that you are admin enabled. So that also you can do using UI. Here in the roles and administrative section. mm, yeah, so you when you after you create a container registry, you can actually make admin enabled. Uh, yeah, so you basically you have to enable it for admin enable, right? So while creating there should be some option using which you can actually enable the admin. Let me do it. Let me do it once so that I can show you. So container history. Let me put a name for it. My okay. Already used. Okay. So I will go with basic, not the standard. Registry name, create new, and review and create next. Letting. I will go with all the default settings, and I will just create the container registry. So by this, we should be able to create the container registry, and the container registry creation takes some time. It will take some time. Um, so once the container registry is ready, you can go to that resource, and somewhere you can mention that. Yeah, so in the access key section, you have to enable the admin user. So with using which you can actually help take this permission username and password that you get it, right? So once you enabled it, you have the username and password for you. So you have this username
you have this password. So these password and username, you can use it for deployment purpose. So you have to copy this username and password inside the environment variables. So in the Travis YML, you have to give this username and password in the Travis YML. So the steps are clearly mentioned here. Um, so um, so like you have to create these environment variables ACR name, right? So ACR name should be there. Um, using the ACR name, you can actually go to travis.yml in the repository Azure container in the settings, right? You go to the settings and here you can actually initialize all the environment variables, which I have already done. So basically ACR name should be actually the container registry name that you have actually just created. So you just need to give the container registry name, which is like my test container registry 2. These values you have to enter it here. Okay. So once you enter it here, after that, you have to go and create other applications, right? So you have to enter your Azure web app name and other things. So next step is like after you have created your container registry, uh, go back to the resources, go back to your resources, resource group. After going back to your resource group 2, here you can actually create your web application. So basically, you according to the steps, you have to create your web application like app services. You have to go to app services. App services. Okay, so you have to create a app service. No, not app services plan. Yep. Okay. So you have to go to app service. No, not this one. Just go create. Mhm. So it is a CA thing that you are do. These are the CA commands that you are using, CLA commands. Instead of that, you can actually do it via portal also. You just need to create web app. You have to provide your web application name. My web app maybe like my web application, and you have to mention the reason. So you have created everything in East US. So similarly here also you can create your own web application. And you have to you are going for free tier, don't go for any paid versions. So go for free tier and then you have to just go next deployment and create, right? So this way you actually you can create your own web applications. So the similar thing you can actually do it via the CLI. So using CLI also you can do, or you can create using portal also. So once I have already created the similar thing here, so in resource group, test resource group, my test resource. So here I already created a few services. So you can just see them. I have already created the same things. So you can just go to that. So this is my basic web test web application that I have created, which is of type web service, right? So this is what I have done. After that, while creating the web apps, you actually give your GitHub repo to which you are tied up with. So while creating, you have to mention your GitHub credentials, and it will be mapped with the repo actually. So once your web application is ready, right? So you just follow the next steps. Like this web app is ready. After the web app is ready, then you have to initialize the variables as mentioned in the steps, right? So you have to mention few environment variables. One of those environment variables is Azure Web App name, Azure Web App Resource Group. These all variables actually you have to initialize. Okay, so after you initialize this web app rules, right? Next step is like you have to create a service principal. So what is service principal? Service principal is similar to a programmatic user, what you can think in this particular context. In this particular context, you need some credentials, some user of Azure who has the permissions to actually deploy it into Azure web apps, right? So next step is to actually you have to create a service principal. So the steps to create service principal are also very pretty simple. Using portal, you can actually create, or you can actually create via UI, via CLI. So via CLI, this is the command that you need to follow. This command, you can actually create service principal. Otherwise, other way of creating is like going to the portal. Here in the portal, you actually go to the Azure portal and you have something called Azure Active Directory. So go to the Azure Active Directory. Here in the Azure Active Directory, you can just create your own, sorry, you have to create your own service principal. So I go to Active Directory, go to add, and you just need to add app registrations. Go to app registrations. And here you can just do a new registration. Create a new registration, give it some name with displayable name, and what you need to connect, what are the platforms you need to add. You just follow the steps which is present here, which is mentioned here, right, in this particular thing. And from by this you will be getting the app ID, tenant ID, and password. So all those things you will be able to get. So you just remember the steps how to actually create app as service principal. All you need to do is go to the active directory of Azure. Go to Azure Active Directory, and then go to app registration, and then from here app registration, create a new registration. And after you create a new registration, right, this is what you will see. Okay, so you will be getting the application ID, you will be getting tenant ID. So this is the tenant ID, this is application ID, and this is the credentials. This credentials will contain the password, username, password details, right? You can see the this is the value of the password, right? So all these values, right? All these values should be stored as enrollment variables, like client ID, tenant ID, everything you can actually store in the Travis enrollment variables, like Azure SP tenant, Azure SP username, and Azure SP password. So these three things you can actually store in these three places. So and also like other variables that you might be needing is like Azure web app name, Azure Docker image name, all these names, right? So you can just enter those values. Azure Docker image name is like something specific to our code. In our code, we have mentioned that we want to enter Azure image name, right? You can give any name, which is specific to, which is of interest to you. So I have given the name, which I already mentioned in the repo. In this repo, I already mentioned that I will give the name it as my app image, right? So I have given the same name, my app image as the name I have given. So after you give this particular, after you fill all these environment variables, then you should be good to go. You should be able to deploy by a single push, right? So you have already configured the Travis YML. The Travis YML is already configured that you can actually verify. You have to follow the same steps. So just make sure that you are having the provider perfect correctly. So just let's open the Travis YAML. You are saying that you are deploying a Docker kind of service, and all the environment variables that you have already filled, like Docker image full name, um, and is it repo name, and few other variables like Docker full image name, and other variables like Travis commit that comes automatically by the commit hash, and so on. Right? These all environment variables that you have actually initialized in Travis.yml uh, in the Azure Web App container will be used. So these all environment variables that you have mentioned, right, in the settings, right? So you just these all values will be used internally by our source code. So all you need to do is like do a push. Uh, Once you do a push of any code, these all environment variables automatically will be picked up, and you should be able to successfully deploy it. So this deploy is very simple. This application just displays a hello world, and after successful deployment, you should be able to see the hello world in your web application. How to go to this particular URL? You just need to go to your web application, right? Your web application already has that particular name. So you just need to click that particular web application endpoint. So you just need to go to that particular endpoint, right? So here you should be given with your endpoint. Just copy this particular endpoint, and you should be able to see this, right? So this actually, this particular report will actually help in deploying for every commit. It will successfully be able to deploy our application, our GitHub, which is there in the repo, directly. It will deploy as a containerized application in our Azure Web Apps. So finally, at the end of after the end of the commit, you should be able to see the deployment successfully going inside our Azure Web Apps deployment, and our endpoint should be able to show the application successfully deployed. So these are the steps. Just go through these steps, and you should be able to feeling comfortable about different Azure web services, right? So we have just gone through brief of we missed a few things like how to assign roles, right? So if you have CLA also, we can just go through these roles. Otherwise, we can also create a role of our own. So the creation of roles are also pretty simple and straightforward. Like to create a role, what you need to do is like you have to go to that particular service. You have created two services, right? We have created two services, right? Those go to each and every service, like go to your resource group, go to the resource group. Your resource group, for example, is my test resource. Go to that resource, and in your resource you should be able to see our services, right? These are the two services: my basic test web services, my test container services. Go to my basic web test service app. Here you should be able to assign roles, right? So here to assign roles, you have to go to this particular section, access control IAM. So on clicking on this access control IAM and go to the role assignments, just go to the role assignments, and you should be able to assign the roles as per your need. Like click on assign, add roles assignment, and what kind of role assignment you have to do. For this purpose, we have to select the contributor kind of role assignment. Click on the contributor role assignment, and then go to next, and then you have to mention the member, the service principal that you have created, right? So go to this particular thing and go to the service principal that you want to create. So I have already created it. I can just recreate it. Maybe like I can just delete and recreate. So go to this particular role assignments. So you can see that role assignments I already have one role assignment. Hmm. Mm, yeah. So I should be able to see my role assignment. I already created it, right? So what is the name of my service principal? My service principal should be there. Okay. I have already assigned it, right? I just want to make sure that my role assignments are there. I will go to container registry, access control IAM, role assignments. Yeah, so I already have this role assignment, so I am not able to see this. So probably I will show you again. So let me remove this first. Let me copy this first. Mhm. Yeah, so let me copy this role assignment. I will remove this role for now to re-edit. So I will remove this role assignment. So I'll remove this role assignment. So I remove the role assignment. Again, I can actually assign. I can go and create add role assignment, and I will click on contributor, click next, and I select user group and service principal and select member. In this member, I should be able to see my role assignment. Yeah, so I got my role assignment, my basic test role assignment. I click on this particular role assignment and click select, and I should be able to review and assign. Now you can see in the top right, it is trying to add role assignment, right? So you are successfully able to assign this particular role, right? So this is the steps to actually do the role assignment via portal. Okay. So instead of doing portal, you can just add the role assignment by the command line. So you have to install Azure CLI for that, and you can do the same steps by using the command line. So you have to add assign roles for both the resources that you have created. One is like Azure Container Registry Service, and the one is the Azure Web App Service. So these two role assignment you have to create, and after that, all you need to do is like the kick off the build. Okay, so it's as simple as like after all the role assignments are done, you just need to do a commit. So once you do the commit, right? Once you do the commit, you should be able to see that your application is getting deployed in a web application. So your web apps of Azure has the your code deployed as a Dockerized container. That's what you see here. So these are the steps. I think the primary steps to create the Azure DevOps service is pretty straightforward. You can just follow the steps which I have mentioned in the README, and I have given a. If you are not comfortable with CLI, you can. I have given you steps how to create using portal, right? So in the portal, I have quickly given you the step-by-step steps of how to create resource groups, how to create different resources. In this Azure, what are resources are typically different services. So each and every service, we in this particular case, we have created only two services. One is the Azure Web App Service, and the other is Azure Container Registry Service. All you need to do is like you have to create these two services, and you have to map these two services with the service principal. I have shown you the steps of how to create service principal and how to assign roles to the service principal using Azure portal service via uh, um, the portal. The steps are to actually go into Azure Active Directory and create a service principal. So here you can just add service principal, going into app registration. So in app registration, you can actually create your own service principal where you will get the specific application IDs, tenant IDs, and password. All this information you have, and you have to initialize different environment variables in our Travis YML. In the Travis YML, service principal related environment variables are these three things. You can see this Azure SP password, Azure SP tenant, Azure SP username. So all these three things are service principal specific password, environment variables, and Azure content registry specific environment variables are ACR underscore name, and web app specific environment variables are these two, and Docker image name specific environment variables are these two. So these all environment variables are internally used within the source code. So in the source code somewhere we are using all these environment variables. You can just look into it. So please go through this README step by step, and you should be very comfortable in creating a Azure Web Apps deployment on committing it into GitHub. Okay. So let's see how it goes. Let's say hello world 2 1 2 3. Okay. Let's say I want to commit this. So I am going to commit it. So I did the commit now. Okay. So I made a small change. Instead of hello world, I am making it as hello world 1 2 3. And by this commit, I should be able to see that my Travis build got triggered. My Travis build got triggered in the master. The job got started, right? You can see that my second commit, which I did a commit right now itself from a code, I changed the hello world to hello world 1 2 3, right? So by doing this hello world 1 2 3, my Travis build got started. Okay. So the job got started, the build process is going on. You can see that step by step. Let's wait for the entire build process to happen. At the end of the day, what would happen is like it will deploy into our Azure Web Apps. Here, you should be seeing the latest deployment. Right now, it is hello world. By the latest changes that you have done it is hello world 1 2 3. So after committing your hello world 1 2 3, you should be seeing that deployment here, right? So let's wait for the build to complete. So the build had started. It has started exporting different environment variables that you had initialized. After initializing the Azure environment variable, it is using those environment variables. It used the Azure repo environment variables. You can see that, and you can see that it is doing Docker pull. It is creating a Docker, and it is pulling off all the node specific related layers. You can see that. So you have already mentioned the Docker full image name also. It got created in our Azure container registry. So you have created Azure container registry, right? Instead of going to Docker Hub, it is actually pulling the image from Azure container registry now. It actually pulled the image from Azure container registry, and many other steps you can see. Okay, so now it is trying to Docker run command has been completed. It is successful. After that, so it is doing the final deployment. It is trying to deploy. It is taking the all credentials. So it is using the credentials that I have given to the Travis via environment variables. So it has taken tenant ID, tenant ID, which it will not display here. It is displaying just secure. Those values are already given by me as environment variables. So it is trying to deploy one by one. It is deploying. So it is deploying the container. It is deploying the container layer by layer into Azure Web Apps. So it is finally deploying and it is done. So the build is exited. So finally the deployment is done completely. So that's what it has done now. So you can just verify. Maybe it will take some time for it to get reflected, or I can just verify now. Yeah, so Mysore, it's not yet reflected. Let's see what is happening here. I think it is still taking some time to get reflected. Mm. So you can just find it like the deploying into Azure Web Apps is also pretty straightforward. You can just try it from your end. Um, so you saw that, right? The deployment is successful, right? So the deployment has been successful, and the latest build, instead of before it was deployed as Hello World, now it is deployed as Hello World 123. So by just doing a git commit, your end-to-end deployment CI/CD pipeline has completed, right? So all you need to do is like any changes that you do is like within minutes it goes to production. So you can see that everything, all the build process is automated, and by one-time configuration in our Azure, we are able to do end-to-end deployment by using a single commit. Okay, so I would encourage you to just go through this particular repository and follow the steps. If you're comfortable with Azure CLI commands, you just go through the CLI commands, or you can just follow the steps that I have mentioned you via Azure portal. You can just follow the steps and you should be able to good to go. Feel free to ask any questions you have if you have in WhatsApp message. If you have any doubts on Azure, then we can actually connect on it also. For now, I think we are good. Let's take a few minutes of break. If you have any questions, just let me know after the break. I will just come back in 5 minutes. Then we'll look what else we can actually cover. I think we have covered a lot, and still we have a lot of time. We can cover a lot more. Okay, so let me take 5 minutes break. Is there a way to pause the recording? Okay, I don't know how to pause the recording. All right, I'm back. So I hope you all guys have understood the CI/CD pipeline in Azure DevOps. Sorry. Yeah. Yeah, so in the last session already I said, like, right, Shankar and Rick, I mentioned that I will try to come up with a working model in Azure services also. So I have shown you demo of how to use how to do a continuous delivery and continuous deployment in Azure DevOps also. So not Azure DevOps, in Azure Web Apps. So basically, I will actually again iterate, because there are a lot of steps I have explained within few minutes. So I can iterate what I am trying to do here. I have taken help of I have taken help of travis.yml to deploy a complete end-to-end solution into Azure Web Apps. That's what I am trying to do using this repo. So I have shared the repo URL in our chat. So probably you can just follow the steps here. So you can just follow. I have already shared this particular GitHub repository, GitHub repository in our WhatsApp group also. Just make a note of this particular repo and follow the steps in the README. So in the README, they have actually clearly mentioned the steps of how to do, how to create resources group, how to create Azure Content Registry resource, how to create app service, how to create web app, and then how to create a service principal, and how to configure all these values, how to assign role to service principal. All these things are mentioned in the README very clearly. And these in the steps also, they have clearly mentioned what are the environment variables that I need to create as a part of Travis build. So all these variables like Azure Web App name, Azure Web App resource group, all these things are already mentioned here in the bottom. So these are all the environment variables that I need to initialize in the Travis settings. So you can just go to this Travis settings and go to settings and initialize the appropriate environment variable values. As you create a service, you will get all the values. Your value are creating those resources and those services, right? So these resources, services, values, password, tenant, username, all those things, you will get it. Those needs to be filled it in the environment variables of a settings configuration of Travis. Okay. So once you fill all these values, right? Once you fill all these values, you should be good to go with the basic CI/CD pipeline. All you need, once you are perfectly done, then you should be good to go with just deploying. So any code deployment, any push that you do in our source code here, it will be immediately reflected. So I have shown you a running demo of making a commit. So I did a simple commit of changing our repo from I have changed the index.html contents, which was actually displaying hello world. I made it to hello world 123, as simple as that. So I did it to hello 123, and it went through the pipeline, the entire pipeline, and just did a deployment of all our service into the Azure Web Apps resources. So it made a fresh deployment, and we could actually see that it got reflected in our Web Apps by clicking into the endpoint. So in the endpoint, we are seeing, instead of hello world, we were able to see the one as hello world 123, which says that we were able to deploy our latest changes into our Azure Web Apps. Okay, so these are the steps that we have followed. So if you are not comfortable with the command line of Azure, right, you can actually do it the same thing using uh, Azure portal. So instead of executing these commands like Azure group create, Azure content registry create, Azure app service create, you can do the same thing using portal. I have shown you a portal way of creating the things, right? So to create Azure resource, what I did is, like, go to the home Azure resources groups, go to resources group, and you can just create a resource group. So this way you can actually create resource group. And afterwards, to create a specific Azure content registry, you go inside the particular resource group. For example, my test resource, you can add specific resources. like container registry, you can just search for container registry. You can search for container registry. You can go for a container registry, and then you can create your own container registry by click on create of container registry. Similarly, after container registry, you can actually create your web app. You can create your app services. So for that, you have to go to the container same as resources. You can search for app services, and you are good to go with app service plan. Okay, so you can create your own app services. You can create your own web app. So web app is there, right? You can create your own web app. So web app, you just click on create web app. So after you create web app, this one, and you should actually create service principles, right? Service principle steps are here. So this is the service principle, which you can actually do it in a portal also. So in the portal, you can just go to the service Azure Active Directory. So go to Azure Active Directory, you can actually go to app registration. So in app registration, you create a new registration and create the service principal. So that way I have created the service principal here. You can see this after creating of the service principal, you will get all these values, which you can use as environment variables in Travis settings. Okay. So you have created a service principals, and you can assign roles to the service principals. You go to you can actually go to that specific resource in your resource group. Go to your resource group and assign the roles, like go to your test container registry, which is belonging to your test control resource. There you can assign by clicking on this access control IAM. So in access control IAM, you can assign the roles by clicking on role assignment. You can verify that I have already added my service principal role here. This is my service principal. Similarly, like my test container history, other services, my web app is there, right? My basic web app, test web app. You can go to my basic test web app, and you can actually assign the particular service principal by clicking on the access IAM and clicking on assign role assignment. And you can see that you can add that particular service principal here also. Once you have given all the credentials to actually access your container resources and your web app resources, you are good to go with the deployment. So by just make sure that you have all the settings, environment variables available here, filled here in travis.yml. Once they are ready, then you can just go for deploy. So once you deploy, the entire CI/CD pipeline will be started, and you can verify it by clicking on the build history. You can see that the build gets triggered, and as a part of build process, it will actually create a containerized application bundle, and it will actually upload and deploy it into our Azure web apps. So that's what we have seen. And finally, after the entire successful continuous deployment, you can see that our endpoint is updated with the latest deployment, and you can see the results here. So that's how you can actually get confidence about how to do end-to-end continuous integration and continuous deployment in Azure Web Apps using the Travis CI. So just follow these steps, and you should be confident enough that you can actually either deploy in AWS Elastic Beanstalk, or you can actually deploy it in Azure Web Apps. So tomorrow you can actually, so once you are comfortable with all these two services, tomorrow you can actually try out with other services also. Probably you can go with GCP also. You can go and try it with the Google App Engine. You can deploy it with Google App Engine by your own. Okay. So by this, we have covered the fundamentals of Docker containerization. Topics what we have covered are topic 10, 11, 12. These 10, 11, 12. Along with that, we have also covered, which I felt like necessary. I have covered. I have gone out of the scope. I have also added new topic, which is not yet there. Like we can actually deploy in Azure Web Services also, because Shankar was more into .NET and Azure specific web services. I thought that I will give a demo on Azure services also, how to do a continuous delivery, a continuous deployment in Azure services also. Okay, so that's all we have covered this now. And I remember like we have a lot of things to discuss in Jenkins. So we did the basic Jenkins, though it was a very good discussion we had in the last session, but there are a lot of things that we can actually discuss about in Jenkins also. So probably in the next session, we will start with Jenkins from where we have left in the previous session. Okay. So last session, we actually discussed Docker and Jenkins together. We introduced the basic fundamentals of Docker and we introduced the basics of Jenkins also. And today we have completed end-to-end about Docker. Okay, we have missed Docker Swarm. If time permits, we'll go to Docker Swarm also. But if time permits, because nowadays I think nobody is using a Docker Swarm much. Okay, so I think it is an optional topic that we can discuss later. First of all, we'll actually cover the fundamentals and the as much as possible about Jenkins, where from we have left in the previous session, and we'll continue and cover the entire topics of Jenkins, and later move to other important topics of DevOps, basically Ansible, Terraform, Kubernetes, Grafana, Prometheus. We go through all these three sections, and we will try to skip for now this Docker Swarm, which is optional, which is not used much in industry nowadays. So probably we can skip it, and later if we find time, we can actually discuss other topics as well. So next session, we will try to complete Jenkins. We'll try to complete the entire Jenkins as much as possible. There are lot of things to learn in Jenkins. Okay, so next session we'll discuss about Jenkins and all the concepts and the way practically we will implement each and everything as much as possible in Jenkins and get hands on it and make sure that we are Jenkins experts by next session. Okay, and later we'll go to other sessions. So as I mentioned. So for now we will close the topic now. If you have any questions, let me know. We can actually have a discussion. Otherwise, we are good to go for this weekend, and we will meet in next weekend. Do you have any questions for me? I hope you will find some time. I hope you will find some time to run through this particular repo, which actually explain about Azure DevOps, Azure Web App deployment. So just spend some time, and I guarantee that you will become experts in. You will be very much comfortable with Azure services, like the basic fundamental dev services. You will be able to understand how the security mechanism of the Azure happens. What is service principal? You will get a real hands-on. So you get an idea of how the basic fundamental security mechanism is implemented in Azure. What is service principal? You will get to know about it, and what are the different DevOps specific services that you can actually use. What is Azure Container Registry? What is Azure Web Apps? What is Azure App Services? You'll get a little bit of idea. Though there are a lot of services, these are the fundamental services that has been covered in this particular demonstration. So just have your hands dirty, spend some time, like it just takes like, as I already given you demo. So if you have caught all those things, like it will just take 1 hour of time, and you should be able to memorize all the services that we have used in Azure. So just spend some time, try to execute them, try to execute on your own, and we are good to go. For now, then we'll end this session for today, and probably we'll meet again next session with the Jenkins. We'll continue with Jenkins. Okay. All right, guys. I am closing the session now. Then, if you have any questions, just let me know. Otherwise, we are good. Okay. Thank you. Thanks, Rick. Thank you very much. Yep. Yep. Thanks, Shankar. Thank you. Okay. Have a good night.